All right, welcome back. We are on day 3, and this will be the first module for day 3. And this day, we're going to go over 3 data structures that are installed by default with Python. So we can build advanced data structures using some of these primitive types later on. Maybe we'll talk about that, but for now, we're going to use the built-in data structures that come with Python. And I'm going to focus on 3. We're going to focus on lists, tuples, and dictionaries. My plan is to give you an overall understanding of all 3 data structures, and then I'm going to go and do a deep dive into each one. So module 2 will go into list and give you some more detail on list. Module 3 we'll talk about tuples and why we have those and what they're good for. And then module 4 will cover dictionaries, which are a key value pairing data structure where we pair things by their key and then the associated value. Just like a real dictionary, right? We look up we know the word and we want to know what the definition of the word is. We look up the word in the dictionary and it gives us the definition. The key is the word, the value is the definition. So that's where we get that data structure. So without further ado, let's jump over to our Jupyter Lab for our day 3 notebook. And let's go ahead and talk about the 3 data structures in order here, and we'll give some more details and some examples. So a list data structure is probably the most versatile and commonly used data structure in Python. It's great because, one, it's ordered. So the order I put things in is maintained. It's modifiable, meaning I can add things, I can remove things out of my list. In computer science term, we call that mutable. It can be changed. And it can also hold elements of different data types. So if you're coming from another programming language, you've probably heard of arrays. Arrays are very similar to list, except for list can hold any object type, and it can vary from item to item. So in this example down here at the bottom, I have it holding an integer, a string, a boolean, and the last is a floating point number. So lists are nicer in the sense that I can hold in different elements of different types, but I also lose some of the flexibility in the speed and efficiency that arrays in other programming languages, and including Python has arrays as well. The efficiency of the way that memory is stored and the ease of use of doing manipulations across an array. But we gain a lot of it in the flexibility on what we're able to do with list. So what I want you to be able to understand about list is they start with a square bracket and end with a square bracket. That's the kind of defining criteria for a list. They are comma separated items in there. So I have, in this case, I have an integer, a string, a boolean, and a floating point number as 4 items in my list. Let's go ahead and use this as our example. We'll go ahead and copy this. And I will go ahead and paste it in here. And let's go ahead and print our list, just so you can look at my list and see how it plays out here. And you'll see it looks just like our definition. And we've seen earlier we can run for loops and go over each item. My list, and I can print out item by item. Hit the run there, and you'll see that it prints out one by one each item in my list. I can also get the length of my list. So let's open up a new coding block here, copy my list over. If I want to get the length of my list, there's a len function. And what I put into that len function is my list. And if I run that, it'll tell me how many items are in my list. That's a useful tool, and we'll probably see that come in handy. I can also do what we saw earlier, is tell us what type our list is. So I can do our print type of my list. And you'll see that it is of type list. One other thing I want to show you with list before moving on to tuples is that I can create a constructor and pass different things in to create a list. So let's call my list here, and let's create it from a string. So if I use my list as a constructor, which is the word list, open parentheses, close parentheses, very similar to our len, our type, and our print. It looks like a method call. And what I'm going to put in there is a string to list. And then I'm going to go ahead and print my list. So what I've done here is I've converted my string into a list character by character. Any object can be stored in a list. We mentioned that Python is object-oriented programming language. We're storing here primitive data types, and we can make more complex data types, and we will when we get into class 6 when we talk about object-oriented programming. But for now, just know that list can hold any object type whatsoever. In fact, everything we've seen is an object type, including a list itself. So yes, a list can hold a list. Let's see that as an example. It's comma separated. I'm going to start a list with square brackets, end it with square brackets, and then I'm going to put items in the list. So now if I print my list, you'll see that I have 1, 2, 3, 4. Then I have a fifth item in here, which is a list of its own, right? So it's actually, how many items do you think are on this in this list? Is it 1, 2, 3, 4, the item 5, or is it 5, 6, 7, 8? Go ahead and think about that for now and tell me what you think, and we'll use the len function, len, to tell us how large my list is. If you guessed 5, you are correct. The items are 1, apple, true, 3.14, and then the fifth item is the list itself. So that is considered one item. It's one object being stored in my list. That item happens to be a list of other items, but it's still, to my outside list called my list, it's just one item. Now I can also access items in a list using square brackets. So I could say my underscore list, and I can say, and they're zero indexed, so this one would be the 0th item, this is the first item, second item. So let's look up item 2 and go ahead and print item 2 out. So we'll use the print command, and you'll see that it prints out item 2 is true. And we mentioned that it's 0 based, that's why you go 0, 1, 2. If I print out the 0th item, you get 1. What if I print out the -1 item? What do you think that's going to do? That starts from the back of the list and says, hey, I want to go here. So the -1 item kind of goes backwards through the list. So the -2 item is going to be our 3.14 variable. So I can go forward through the list starting at 0, or I can go backwards through the list starting at -1. What if I go outside the list? So I know there's 1, 2, 3, 4, 5 items. What if I want the 6th item? That's when we're going to get an error. So it tells us that we're out of range of what our list contains. And I also mentioned one of the most common mistakes is, since we do start at 0 based, it goes 0, 1, 2, 3, 4. The most common mistake people make is starting at 1 and saying, okay, 1, 2, 3, 4, I want the 5th item. And then when they run their code, they get the index out of range, because there's really 0 through 4 is how we access it. And which is counterintuitive, because if I print the len of my list, you'll notice that it tells us it's 5. So why can't I access the 5th element in there? It's because it always goes 1 minus the length. So I can go 4. Okay, that's all I really want to cover for list for now. We'll come back to list in the next module for day 3, and we'll do it in a lot more detail. But the big takeaways are starts with a square bracket, ends with a square bracket, and everything in between is comma separated are elements that are inside of my list. My list can hold any object. Everything in Python are objects, so it can hold anything in Python. And we can also change it, meaning I can add things and subtract things and modify the list. So we'll see that next lesson. And also know that it is one of the most common data structures used because of this flexibility. Okay, the next item I want to talk about are tuples. So tuples are very similar to list, but the big difference are they are immutable, meaning you cannot modify them at runtime. So you create them during build time, like when I'm writing the code, I can make them, but then once I start running my code, I cannot change the value of a tuple. I can create a new tuple and destroy my old one, but it's going to be a totally new variable with a new pointing to a new memory space. I'm not actually modifying the values that are at the that are contained inside of a tuple. Now the big difference between lists and tuples is the starting and closing is done with parentheses. So not square brackets. For list, we're doing it with parentheses, which create a tuple. Now, just like we did with list, I'm going to go ahead and show you we can do pretty much the same thing. Right? I can do that for loop for item in my tuple, and I can print out the items. And it gives me my individual items just fine. So just like I can iterate over a list, I can also iterate over a tuple. Just like I can construct our list, we created a list from a string. We can create a tuple from a string using the tuple constructor, meaning I use the word tuple, I put my string in quotes, and I surround it by the close. So I have open and close. That's encapsulating my call to the tuple constructor, and now I can print out and go ahead and run that, and you'll see that each element each character is an element now in my tuple. And you'll also notice when I print out, it prints out with parentheses rather than square brackets, because I converted my string into this immutable data type called tuple. Now tuples are ordered, meaning the elements, the way I put them in, matter, right? Just like I did with the list, this is the 0th item, this is the item that's in the 1's place, this is the item in the 2's place, and this is the items in the 3's place. I can index into a tuple just like I did with the array. So I can say something like, well, let's copy this. And let's say my tuple. And then I can square bracket index into it and say 0. And let's go ahead and print this out. And that's the 0th item, which happens to be 1. What if I do the first item, which happens to be the word apple? Now, I know what you're thinking, and I get this all the time when I teach this class. If tuples use parentheses to open and close, why do I reference them with a square bracket? And that's the nature of the way that we use things differently in our programming languages for different reasons. Parentheses here are used as an encapsulation for a method call. This method happens to be the constructor for tuple. So this Control Z that. This parentheses is not in any indication that this is a tuple. This is an indication that it's a method call. Just like when I did my list for the constructor call, this is a constructor call to the method list, started with parentheses and ended with parentheses, but I still created a list which has square brackets. Then we index into things, which is a different thing than creating. So we're reusing the square brackets. And this square brackets here is not because it's a list, it's because that's the way we index into items. It has nothing to do with the fact that it's a list that I'm using square brackets. It just so coincides that lists use square brackets for designators, and then we're reusing the same character for a totally different meaning for a different purpose. So I'm indexing in with square brackets, and everywhere I want to index into things, I'm going to use square brackets. In fact, if I have a string, this is my string, I can also index into a string with square brackets as well, right? And I get the value of h, because this is now a list of characters, item by item, and the 0th one is t, the first one is h. So if I want to get -1 here, what letter do you think it's going to print out? Remember, -1 goes backwards through the list of items, so I am going to get the letter G. So square brackets are used for lists when I'm creating them. It's also used for everything for indexing into things. So you'll see us index into dictionaries with square brackets, list, strings, anything that's what we call iteratable, where I can iterate over items. I can use the square brackets to access into it. So we reuse characters in the programming languages for different purposes. Okay, so when I'm creating tuples, I use parentheses. When I'm creating a call into a method, such as print, I use parentheses. So that just kind of shows you the print method. Everything that's in between this parentheses and this parentheses is what gets passed into my print method. In this case, what gets passed in is my tuple in the first item, which is apple. Okay, so the big takeaway for tuples is that we use parentheses when we create them. Once we create them at design time, we cannot modify them during runtime. So once they're initiated, they cannot be changed. Now I can change it now because I'm in runtime before I actually run the code, right? I can say, hey, let's create a list in here, just like we did before with the list. And yes, tuples can hold objects just like arrays can, or just like lists can. And so they can actually hold any object, so I can put a list inside of a tuple. And you'll see that it does, in fact, have the single item of a list inside them. Now watch this. This is kind of a fun one. I can, if I grab this as my example, actually let's go at the bottom here so I don't confuse people too much. I'll cut these out. Alright. Alright, so I've got my tuple with a list in there. What if I want to get a list out of it? So I can say my list is equal to my tuple. I'm going to index in and say -1. Now let's do a for loop over my list. And let's print out the items. All right, now I want you to pause the video and just think about what's going to happen when I run this code. Like, what do you think the output is going to be? See if you can, in your brain, play the role of the Python interpreter and see if you can figure out what do you think is going to get printed. All right, welcome back. Hopefully you were able to come up with the idea that it's going to print out the items 1, 2, 3, 4, 5. Let's kind of unpack what's going on here. I created a tuple, starts with parentheses, ends with parentheses, that has how many items? Well, it has 5 items, right? It has the integer, it has the string, it has a Boolean, it has a floating point number, and it also has a single item called a list. That list just happens to pack extra items in it, so it's got multiple items in the list. So my list is developed from my tuple -1. So I look at my tuple and I go the reverse way back and I say, okay, that's the value of tuple minus 1, so that's what I'm going to assign to the variable myList. So now myList is taking and holding in its place these values. Then I do a for loop on those values, 1, 2, 3, 4, 5, and each time through I print it. And that's how we got from a tuple that contained a list, we pulled the list out of it, and then we ran a for loop over the single items that are contained in that inner list that's contained in a tuple. All right, we will go over more tuple functionality in Module 3, but that's kind of the gist what I want you to get, right? So it looks just like and acts almost like a list, except for that I can't change it. And you'll see what I mean by changing it at runtime when we talk about lists next module. The reason why we use tuples often is for data that we don't want to have modified, right? I don't want to have, if I pull data out of a database that's read-only, and I just want to show linked fields that are from a database table, I don't want it necessarily get modified, so I want to have it in a read-only form. So tuples are typically used for creating data out of a database. All right, the last data structure that I want to go over is dictionaries. Dictionaries are key value pairs, and basically is a lookup ability for us to look something up by a friendly name rather than having to need to know the index into something. Right? When I look at the tuple, if I want to get out 3.14, I need to know that it's the 0, 1, 2, third item to be able to print out the third item out of that tuple. With dictionaries, I don't care about necessarily about the order that things are in there. I care about the friendly name that I can remember. Like I can remember, oops, like I don't, not double clicking there. I can remember name, I can remember age, and I can remember city, and then I can look those values up based on the friendly name that I can remember, and I don't need to know where in the data structure that that data resides because I can do a lookup based on the key. In other words, the noun, or not the noun, whatever the word is we're looking up in the dictionary, like if you had a tabletop dictionary and you're looking up certain words, as long as you know what word you're looking up, you can get the definition, no problem. So that's the key value idea. Now the way we develop dictionaries is with the start is with a curly bracket and the end is with a curly bracket. So I completely encapsulate everything about my dictionary between curly braces. Then I have two values together, a key and then a value, and I separate them with a colon symbol. So these two, name and John, are associated. Name is the key, John is the value, and they're separated by the colon. Then another entry in my database, so that's the comma sign, is the key value pair of age and 25, and then comma, the third item in my dictionary is city as the key, and then New York as the value. Now, we've talked about a little bit about immutable and things that can be changed, things that are mutable. So immutable cannot be changed, mutable is changeable. The key here has to be something that is immutable, cannot be changed. Strings are good examples of that, numbers are good examples of that, and tuples are all good examples of things that we do not change. But a list, if I put a list as a key, that's going to be a major issue in a dictionary. We cannot do that because it has to be something that's immutable, does not change. Now, however, the value can be of any data type. So any object can be stored as the value. In this case, the value is John, 25, and New York. I'm going to run this as our example here. I'm going to copy this. Hit our Control C, and then we'll go ahead and Control V. And we'll go ahead and hit run. And now we've stored my dictionary. Let's go ahead and do a loop as our first example through it. We'll call this key in So when I use a dictionary to iterate over in a loop, it gives me back the key. So if I hit run, you'll see I get name, age, and city. Name is the key, age is the key, and city is the key. What if I want to get the value instead of the key? The key is great for looking stuff up, but I care more about is the value that the dictionary contains. What I can do is I can take my dictionary and I can do a lookup. Now, before we looked up by index, right? So I just said something like 0 for the list and the tuple. Dictionaries don't use indexes, they use keys. So I have the key here, so let's go ahead and use the key. And what's going to run now is instead of printing out my keys of name, age, and city, it's going to use name, age, and city as the lookup every time and give me back the values. So I'm going to get John, 25, and New York. So you can start to see how dictionaries are very powerful because I can, in my code, can remember I asked the user to put in their address and name and all the metadata about that person. And now I can do something like look it up. I can just say, okay, I want to, if I store it in a data structure of a dictionary, I can say, I want to get their name. And let me print that out. Now let's not print this out. So how do we not print stuff out, but we don't want to lose it? I'm just going to go ahead and comment it out. So there's a good use of comments to keep our code efficient, and I don't want to necessarily delete it. But you can see that I can look up the person's name from the dictionary. And I could do my fun string concatenation. I can do something like anything I can do with a string, I can do with a dictionary value that is a string as well. So I could say something like welcome and put their name in there. And so I get welcome John. And I store this in a dictionary. Now, dictionaries, different from, let's go back there. Okay, dictionaries that are different from lists and tuples, because lists and tuples, I can store multiple items of the same thing in them. So for instance, if I have, we'll call it my list, and I'm going to have it hold with square brackets. I'm going to say 1, 1, 2, 2, 3, 4, 5, 6. Right? And I've got duplicates. I've got 1 in here twice. I got 2 in here twice. And that's just fine, right? I can print that out. And then I can do the same thing with a tuple, where I can have multiple items. And we'll change this into a tuple by using parentheses. And let's rename it to. Go ahead and run that. And it works just fine. But let's see what happens when I do a dictionary with multiple of the same thing. So let's copy John. And we'll do a comma here. Instead of John, let's do Sam. I've got 2 keys with the same thing, and that's a no-no in dictionaries. Well, it's not necessarily a no-no. It has a meaning, and it's not as intuitive as you would think. Let's go ahead and print my dictionary. And you'll see that it does have the name Sam in there, but it does not have the name John. What happens is the name key will point to the latest thing of value that's been assigned to it. So in this case, name was assigned to Jonathan. Then it went to the next item and says, okay, I'm overwriting what name means, and I'm going to put Sam in there. So I'm deleting the name John and adding the word Sam in there. So that's why name is in here, but it's only in here once, and it's got Sam's name in here, because this kind of like overrides it. So dictionaries can only have one meaning. So this is somewhat intuitive, like you can say, hey, I want to update my dictionary. In fact, dictionaries are mutable, so they can be changed. The keys, however, are immutable. Once a key is set, it's set in the dictionary. So let's look at something like my dictionary. We're going to look up by age. And I'm going to print that out. Let's go ahead and print by age. And go ahead and, oops, what did I do wrong here? Oh, I didn't put it in quotes, so I didn't make it a string. There we go. So you see I get the value of 25. But now let's update my dictionary of age and say that it's going to equal 55. So when I reference into the dictionary using the square brackets and the key, I can overwrite, I can do an assignment into that value, or in that overwriting the value that was previous there, which was the value of 25. I'm now overwriting it and making it 55. So when I run this code, you'll see that initially the dictionary had the value of 25 in here, but when I print out the dictionary after modifying the age is now 55. So dictionaries do not allow for duplicate keys. If I use the key again, it updates the value. That being said, values can be reused over and over again, right? So let's see how that works. So name, let's do last name. Last name, and I'm going to make this last name also be John. So his name is John. And you'll see that I can have the value John and the value John in here, no problem. But I can't have multiple names in here because it'll overwrite. Okay, so that's really what I want you to understand for dictionaries. They start with a curly brace, end with a curly brace. That kind of encapsulates everything in them. Then they're pairs of key values. So I have a key first, colon, then the value. And then comma separates all of my different items that are going to be in my dictionary. Dictionaries have to have what's called immutable keys, meaning they cannot be changed. Strings are good examples of that. Numbers are good examples of that, and tuples are. Lists are not, because you can change a list. So we don't tend to put list as our key in a dictionary, because that would be give us unknown responses, or unknown way that it would handle that. All right, but our values can be of any object that works in Python. So any object I could store. Instead, let's do, we can change our dictionary here. What did I do it last here? We'll add another field, and we'll say, we'll just call it key. Actually, no, we'll call it list. And the value is going to be a list. 1, 2, 3, 4, 5, 6. Copy this, paste it down here, and now let's print out my dictionary. We're going to index into it the word list. And you'll see that gives us back our list. So this is totally mutable, can be changed, no problem, but I'm storing it as a value, not as a key. My key is a string. So that's perfectly valid syntax. Now, I've never tried, so this is going off script a little bit. What if I make my key that, and then the value to be list? Oops, not comma, I want to do colon here. So I've inverted this. I've made my key the list, and then the value to be the word list. I don't think this will work. Let's see what happens if I comment this out and run it. Yep. Unhashable type called list. So because this is mutable, meaning it can be changed, I cannot use it as a key type in dictionaries. All right, so that's a lot to take in. Go ahead and take a break, and when you come back, we will start doing a deep dive into the list data structure and find out all the cool functionality that lists provide.